This is brand new. You've never seen anything like it, so I need you to tune in and really slow me down. We are going to be doing absolute value equations, and you've not seen this before, not in an equation. So there is a lot of formatting that you have to make sure that you do correctly. And will I count off for it if it's not formatted correctly? Absolutely, I will count off if it's not formatted correctly. So pay attention, use a highlighter. This is brand new. All right. How do you solve absolute value equations? Your first step is you're going to make sure the absolute value expression is isolated. That means it's by itself. So I'm just going to quickly show you what isolated means. That way you kind of know what it's talking about. If you look in your notes, oh, this is moving so slow. My absolute value expression is located on one side of the equation. So it's by itself because you have that set equal to 2. Look at number 3. Is this guy isolated? Yes. Everything that's in these absolute value brackets is by itself on one side of the equation. So number 3 is isolated. Look at number 5. Is 5 isolated? Yes. Even though it has 2 terms, that absolute value is by itself on one side of the equation. That's what it means to be isolated. Look at number 7. You got lots of things going on. It is isolated. It is by itself on one side of the equation. Jump down to number 9. Look at number 9. Number 9 is not isolated. It's got this positive 2 by it. So my first step here would be I have to isolate it and get it by itself. Okay, that's what isolated means. So number 11, look, you have this 6 outside that absolute value expression. Not isolated. You have to get it by itself first. Same thing with number 12. You've got that negative 2. Not isolated. You must get it by itself first. And then look down at number 13. Look at these. Look at these. Look at 15 and 16 and 14. Definitely not isolated. You've got to get rid of that 6, then get rid of that 7 to get that absolute value by itself. So hopefully you know isolated versus not isolated. Okay, now, that's the first step is understanding what isolated means. So now that you know what that means, we can move on to step number 2. So once it's isolated, step number 2 says we are going to set the inside, whatever's inside that isolated absolute value, we're going to set inside equal to both the positive and negative number from the other side. That's easier when we look at it. Step 3 is we're going to solve both equations. And then step 4 is we're going to write your answers as a solution set. Now, this is a vocabulary word. This is brand new to you. And this is something that you must do. It has to be put in brackets. Well, I don't know how to write a bracket. I don't know how to do it. I'm just going to write a parentheses. You can, but I'm going to count it wrong, okay? You have to learn how to write a bracket because in algebra, a bracket means more than one solution. Parentheses means you're going to graph something. Bracket means more than one solution. So it is imperative that you know how to write those brackets, okay? And we'll talk about that when we get to some examples. All right, so let's take a look at number 1. All right. And talk about the vocab of what that means. So step 1, it's isolated. Step 1's isolated. Now, here's what step 2 means. It means set the inside, x, equal to the positive value on the other side, and set the inside equal to the negative value on the other side. Notice, whatever is in my absolute value does not change. X and x. The only thing that changes is this constant term. One of them is going to be positive, one of them is going to be negative. Okay? Now, I don't need to solve because it's telling me x is 2 and x is negative 2. So there's nothing for me to solve. But step 3, after we solved it, step 3, step 4 is we have to put it in bracket forms. There's 2 solutions to this. So watch how I do it. X is the variable I'm talking about. I set it equal to, here's where my brackets come into play. Notice how I draw it. It is a half circle, an arrow, and another half circle. I don't care if you're not good at it. Practice it. You need to be able to do it. And then I'm going to do least to greatest. So -2 comes, and then 2, and then I'm going to do the bracket again. Okay, that's my final answer. Now, let's talk about why. Why is there 2 answers? Because remember what absolute value means. It means your number line. It means that x could be -2 because the absolute value of a -2 is a +2. Remember, absolute value can't be negative. So absolute value of -2, that means the distance is 2, and the distance is 2 when it's +2. So you have 2 answers. X can be -2 to make it 2, and x can be +2 to make it 2. Okay, that's why you have 2 answers for absolute value. All right, let's take a look at number 3. We're going to do a few of these. So, all right, step 1, isolate. It's isolated. Now we're going to branch. I want to see your branches because we're making 2 equations. We're setting the inside, 5z, equal to +40, and we're setting the inside equal to a -40. Step 3 is to solve. I divide both sides by 5. Z equals 8. I divide both sides by 5. Z equals -8. I have 2 answers. And so now Z is the variable I'm talking about. I set it equal to brackets, least to greatest. Because inside here can be -40. The absolute value of -40 is 40, and the absolute value of 40 is 40. That's why we have 2 answers. Now, well, I won't even tell you that because I don't want to get you off. All right, let's do number 5. Okay, this is isolated. It is isolated. So now I'm going to branch. I want to see that branch. I'm setting the inside, d plus 1, equal to the positive value of 8, and I'm setting d plus 1 equal to the negative value of 8. The inside has not changed. Now I solve. Subtract 1, I get d equals 7, subtract 1, and I get d equals -9. So notice your answers aren't always going to be opposite numbers. So don't get in the pattern of, oh, I solved one for 8, the other one's going to be -8. No, it's not. Chances are it won't be. So make sure you're solving both equations. D equals -9, 7. So least to greatest, least to greatest, least to greatest. Let's take a look at number 7. Okay. First step is isolate. It's isolated. So once it's isolated, now we branch, and I set the inside equal to the positive value of 34, and then I set the inside equal to the negative value of 34. And I solve. I subtract 2. 4n equals, I divide over here. I subtract 2. 4n equals -36. I divide by 4. N equals -9. And then I put it in brackets, least to greatest. Okay? All right. Let's take a look and see what happens when it's not isolated. So we've already established what is and is not isolated. Well, our first step is isolated. You guys know how to manipulate an equation. So if I need to get this absolute value by itself, I got to get rid of that +2. How do I do it? Additive inverse. I subtract 2, and whatever you do to one side, you do to the other side. Subtraction of equality. So that's canceled out. Now it's isolated. And after I isolated, I branch. I set the inside equal to the positive value, and I set the inside equal to the negative value. No need to solve. C is already by itself. So now I put it in brackets, least to greatest. Okay? All right, let's take a look at number 11. All right, first step, isolate. How do I get rid of that coefficient of 6? Divide. I divide both sides, division, property of equality. Now I get absolute values equal to 4. Now that it's isolated, now I branch. X equals 4, x equals -4. No need to solve, it's already by itself. So in brackets, least to greatest, -4 to 4. All right, let's take a look at number 13. So I need to get rid, remember you can't add 4 because it's not isolated, so you can't even do that. But you've got to get rid of this fraction. It's over the whole, this whole absolute value is located over 6. So my first step is I got to get rid of that dividing by 6. Multiplicative inverse, I multiply both sides by 6. Remember, I want to see it up here because I want to see that cross reducing numerator and denominator. Whatever you do to one side, you do to the other. Now I have 2w minus 4 equals 18. The absolute value of 2w minus 4 equals 18. When you branch, those absolute value brackets fall away because we're actually solving at that point. Here is where you have absolute brackets. Once you branch, now you just set the inside equal to the positive value, and you set the inside equal to the negative value. And we go about our business of solving. Add 4, so 2w equals 22, w equals 11. Here, add 4, 2w equals -14, w equals -7. And then I put in brackets, least to greatest. Okay, so steps, isolate, branch. This you must have absolute value. Once you branch, these guys fall away and you just set up your two equations, okay? And then solve and bracket. Let's take a look at number 15. Actually, no. Yeah, well, let's do 15. I'm going to do 15 and 16. I love fractions. All right, so over here, it's the same thing. You've got to get rid of your constant term first. So I'm going to add 6, additive inverse, and I get 7. Absolute value of that equals 112. Now I'm going to divide both sides by 7, and I get absolute value of 4n plus 8 equals, remember short division, 7 goes into 11 one whole time with 4 left over. 7 goes into 42 6 times. All right, now absolute value, isolated. After it's isolated, now I branch. Those absolute value brackets go away, and I set the inside equal to the positive value, and I set the inside equal to the negative value. And I solve. Subtract 8. 4n equals 8. Divide by 4, n equals 2. Over here, I subtract 8. 4n equals -24. N equals -6. And then I do brackets. N equals least to greatest, -6 to, and then I move on. Now, let's do number 16, because I love a fraction. So I'm going to add, get rid of your constant term. I'm going to add 24 to both sides. I get 3/2. Absolute value is now going to be equal to 3. How do you get rid of this 3/2? Multiplicative inverse. You multiply by 2/3. You multiply by 2/3. My 3's cancel out, my 2's cancel out, and I'm left with the absolute value equals 2, because my 3's cancel out. These are not difficult. Just know your properties. Now, absolute value, it's isolated. What do? We branch. 4r minus 4 equals 2. 4r minus 4 equals -2, and here we solve. So 4r equals 6, r equals 6/4, so r equals 3/2. Here I add 4, 4r equals 2, divide both sides by 4, r equals 1/2. And then least to greatest, 1/2, and 3/2. No need to turn that into a mixed number, you can keep it improper. Okay, now, you're going to want to get in the pattern, and then you're just going to explain it. And you're just going to want to go through the steps and not think through. If your absolute value bracket is isolated, and on the other side there's a negative number, this is not possible. That is not possible. Absolute value can never be negative. Ever, ever, ever. So, what you have to do is before you start going into solving and branching, you have to ask yourself, absolute value can never be negative. So whatever's in here, this guy cannot be negative. If it is, stop. You can't solve it. Now, over here, it looks positive like you can solve, but we're not isolated yet. So you have to first isolate, and then I get 2x plus 1 equals a negative 7. This guy can never, ever be negative. So if you get in a situation like this, there is no solution. Absolute value can never be negative. But you cannot do it unless your absolute value is isolated. Okay? If this is making sense or tricky, come see me.